So we're going to be looking at probabilities that involve an at least modifier. So probabilities of like at least picking two boys, or at least doing this, or at least doing that. So remember, at least means it can happen once or more. So that kind of presents a few challenges for probabilities, because not only do we want this thing to happen once, but we also want the chance of it happening more than once, like twice, 3, 4, 5, 6, as many times as it can. So we have to account for all those situations, which makes it a little bit different than normal probabilities. So we'll take a look at a basic one here first. If we roll 2 dice, what's the probability that we roll at least 1 1? So if you think about it, all the possibilities of rolling 2 dice, well, there's 6 possibilities for the first die, I should say. 6 possibilities for the second die, 36 possibilities total. Okay? We want to figure out all the possibilities that have a 1 in them. Okay? We want to figure out all the possibilities where we roll a 1. So we could have a 1 on the first die, and then roll a 1 2, a 1 3, a 1 4, a 1 5, or a 1 6. Or we could roll a 1 on the second die and roll a 2 1, 3 1, 4 1, 5 1, 6 1. Or we could roll double ones. So it's a total of 5 possibilities over here, 5 possibilities over here, 1 possibility down there. It's a total of 11 possibilities total. So there's 11 possible different rolls that give me a 1, whether it be 1 1 or 2 1s. And there's 36 possible rolls I could pick in all. So the probability of getting at least a single 1 is, or rather at least a 1, is 11 rolls out of 36. Now there's another way we could have done this. Instead of figuring out directly how many rolls have a 1 in them and then figure out the probability from that, which is a direct approach, we could say how many rolls don't have a 1 in them. So if 11 rolls have a 1 in them, that means that if there's 36 rolls total and 11 have a 1 in them, that means 25 of them don't. So what I could have done is, instead of doing it directly, I could have done this. I could have said 25 out of 36 rolls don't have a 1 in them. I'm then going to take that fraction. Whoops, let me try to write this again. I'm going to take that fraction and I'm going to subtract it from 1. Because remember, 1 in this case is like 100%. 1 is representing all the possible combinations I could get in any situation. So I'm going to take out all the possible combinations with the 1, and what I'm left with is all the possible combinations that don't. Or rather, I'm going to take out all the possible combinations that don't have a 1, and what I'm left with is all the possible combinations that do have a 1. Okay? That's what 25 out of 36 is. 25 out of 36 is all the possible combinations that don't have a 1 at all. 11 out of 36 are all the possible combinations that do have at least 1 1, if not 2. So instead of getting it directly, what we did in the third section there is we figured it out indirectly. We figured out what's the chance of it not happening, and then we said, okay, if I know that's this chance not happening, that means it has to be this chance of actually happening. And that's how we do the other two, because for 1 roll, it's not that bad. But when I get to 2 or 3 or 4 or 5 rolls, figuring out all the different possible ways I can get at least 1 would be very tedious. Because I can figure out what's the chance of getting a 1 on the second roll, a 1 on the third roll, a 1 on the first roll, a 1 on the first and second roll, a 1 on all 3 rolls, a 1 on the second and third roll. There's just a lot of different possibilities to go through. So instead of going through all of that, we just decide, let's figure out the chance of not getting any 1s, and then just do the reverse. So if we roll 2 dice twice, not to be rhyming at all, what is the probability of getting at least 1 1? Well, the chance of getting no 1s, okay, that's what we're going to figure out first. We're going to do indirect approach here. The chance of getting no 1s at all on the first roll is 25 out of 36. The chance of getting no 1s at all on the second roll is also 25 out of 36. So I'm going to multiply these together to get the chance of getting no 1s in either roll. Okay? So this probability that I'm about to get here is 0.4822. That is the chance of getting no 1s at all in either of your 2 rolls. So what's the chance of getting at least 1 1 in those 2 rolls? Well, I'm going to take 1, which again stands for 100%. I'm going to subtract off all the possible things that I don't want. Okay, so that 48 point or that 0.4822, that represents all the possible things I don't want. I'm going to take that away from 1, and what I get is the chance of it actually getting at least 1 1. Could be 1, could be 2 1s, could be a various amount of things, but that's the chance of it going to be at least 1 1. So that'd be 0.5177, or roughly 52% if you round it off. Because what I did is I started with 100%, I took away all the things I don't want, and what's left is 52%. So that's the chance of what I do want happening. So it is an indirect approach. Instead of going there directly, instead of figuring out directly what is this going to work, or how is this going to work, I'm going to say, what's the chance of it not working, and then just taking whatever's left. Okay? I'm finding out what I don't want, because then I can just figure out what I do want by what's left. So it's an indirect approach. Let's try another example here real quick. If we do it 3 times, and you should start to see a pattern, right? Here we did 1 roll, right? The first one, we did 1 minus 25 out of 36. On the second roll, we essentially did this. We did 1 minus 25 out of 36 times 25 out of 36. Okay? We did that. So if this was for 1 roll, and this was for 2 rolls, the third roll is going to be very similar, right? It's going to be the chance of me getting no 1s in 3 rolls, which would be 25 out of 36 times 25 out of 36 times 25 out of 36. It will be that big decimal there, or if you want to keep it as a fraction, you could. It'd probably be easier to do it as a decimal because you are going to be taking away from 1, which might be easier in decimal form. But as you notice here, every time we tack on another roll, all we do is we tack on another fraction, because all we're doing is rolling the die 1 more time, which is a nice little thing about this, is that all you need to do is just keep adding another fraction every time you want to add a new roll. So this would be about 0.3349. So what you would do is, like before, you would take 1 minus 0.3349, and the chance of us getting at least 1 1 in 3 rolls is about a 66.51% chance. And it's good that it's higher, because the more we roll, the better the chance of us getting at least 1 1, right? So these probabilities should be going up the more rolls I do. So every time I roll the die, the more I roll it, the better the chance of me getting at least a 1. So if you can see the pattern for the first one, okay, if I scroll back up here, that's very slowly, there we go. If you can see the pattern for the first one, which is just 1 minus what we don't want, then the second one is just 1 minus what we don't want twice, because we don't want it twice. We don't want it on either roll. And the third one would be 1 minus what we don't want 3 times. The fourth one would be 4 times. The fifth one would be 5 times. And you can get as many rolls as you desire in there. Okay? But that's the pattern that we go for. We are subtracting off everything we don't want. That way what's left is the stuff we do want. It's a very different way of approaching math problems, one that becomes very prevalent in higher levels of math. But it is a way to do it nonetheless. In fact, it's probably the only or the most efficient way of doing at least probabilities, just because trying to get exactly just the ones you want by hand or even by mind is going to be very, very tiresome. It's much easier to figure out all the stuff you don't want, because there's more of what you don't want. So figure out all the stuff you don't want, figure out what that is, and then just throw that all away, and then figure out what's left. The key thing to remember here is that number 1 represents 100%. So 1 is kind of like the center of everything here, of all possible outcomes in that situation. So whatever you take away from 1, whatever's left is going to be the opposite of what you had. So if you're going to take away all the possible rolls that don't have a 1, whatever's going to be left is the possible rolls that do have at least 1 1. Hope this helped you out. Have a good day.